This video is going to go over writing exponential functions / equations. So there are the three types of equations you see when you're writing them out. We've already seen the first one, which we saw when we were graphing them. And so this is the general exponential equation, and this can be either growth or decay. So remember, that's dependent on your b value. If it's a growth, your b value is going to be greater than 1, and if it's a decay, then your b value is going to be between 0 and 1. As mentioned in the previous lesson over graphing, your a value is going to be known as your initial amount. So that's your starting amount. So like if the problem says you bought a car for $20,000, then that's going to be your a value, your initial amount. And that's actually the initial amount on all of them. So a means the same exact thing for all three types. Now, let's go ahead and just focus on this first one for a second. So the previous lesson we talked about what b meant, which is the growth factor. When we're writing word problems, your growth factor is also known as your rate. So what does that mean for the rate? Well, your rate here in the word problem is going to be typically written as a word. And you're like, well, what does that even mean? Like, lots of things are words, right? So what I mean by your rate as a word, examples would be it's saying that something is being halved, something's tripling, doubling, like doubled. So it's literally writing out the word saying it doubled or tripled or quadrupled or split into thirds. So it tells you as a word, okay? So you have to know which one of these equations to use. You can't just pick the same one for all word problems. So the first one is if you see that your rate is a word, that's when you would use that one. Okay, so let's go ahead and look at these next two. These are the ones that go hand in hand with each other. So again, the first one can be growth or decay. So it's always going to be a possibility for any word problem as long as you can determine whether it's growth or decay, right? For these two, you have one's growth and one's decay. If you notice and look at the equations, they're exactly the same except for one little bit. This one has a plus in the middle, and this one has a minus in the middle. So it's going to be exactly what you think. The first one, or the second one in the middle right here, is a growth exponential equation. So this is like something's growing, like your bacteria is multiplying. That would be considered a growth. And then that means that this one would be decay, which means like a value of a car is decreasing, right? As soon as you drive a car off a parking lot, it's no longer worth what you bought for, so it's decaying in value. So again, the plus sign tells growth, decay means minus. Now, what would the R mean? Well, the R would mean a rate, and you're like, well, how is that different from the rate in the first one, right? Because the rate in the first one is words. Well, the rate in these have to be percentages. Okay, so for example, if it says it's increasing by 17% every month, okay, then from immediately off the bat, I can eliminate this one because it can't be that. So again, these are our three possible equations that we could choose from, and we go through that list to see which one of these makes the most sense. So it will make a little bit more sense as we go through some examples together. So again, the percentage is written, or the rate is written as a percentage. Okay, and then T will represent the time. So if it's saying it's for 5 days, 3 years, something like that. So it's going to be your time. Now, the important thing to note about the rate here is you want the rate as a decimal. So it will give it to you as a percentage, but when you plug it into the equation, you want to write it as a decimal. So for example, if it's saying something is decreasing by 15% every month, if you were to plug this into the equation, you would want to write it as a decimal. Well, 15% as a decimal is 0.15. If something is 85%, that's going to be 0.85. If something is 5%, it would be 0.05. So you basically move your decimal place over to the left. So you want to write it as a decimal. So I'm going to go over two problems. I'm going to go over one where we have a percentage rate and another one where we don't have a percentage rate and we have a word rate. So I'm going to go ahead and start with number one. You take out a loan for $4,500 and the bank charges you 6% interest. How much do you owe after 5 years? So when you go to the bank and you ask to borrow money, they're going to charge you some interest, which means you're going to owe them back the $4,500 that you borrowed, the $4,500, but they're going to add on interest that you have to pay over the years, which means you end up owing even more than you actually borrowed. So the amount that you owe actually increases, okay? So when you're going through these types of problems, there's two questions you always start with, okay? The first question you always should ask yourself is this growth or decay? Now, here's why we would ask ourselves this. If I know it is decay, right? If I know that the problem is decay, then I automatically can get rid of the second one because the second one is a growth equation. So I would eliminate it. Now this one never gets eliminated right off the bat because it can be either. So the first question you ask, you can always at least eliminate one of them. So is this growth or decay? Well, like I said, if you're borrowing money from a bank and they're charging you interest, the money you owe actually ends up increasing, which means you're going to owe even more in the end. So your amount that you owe is going to be growing. Okay? So this would be a growth. So if this is a growth, then which one of these can you eliminate? I can automatically eliminate the one on the right because it's not a decay. So it's not going to be that equation. I'm not going to use that. So that's the first question you should always ask. Is it growth or is it decay? The next thing you should ask yourself is, was the rate given to me as a word or a percentage? Because remember, that's the difference between these problems, right? The first one, my rate is always written as a word. Tripled, halved, so and such. Or so-and-so, there we go. But the second two, the rate is given as a percent. So if I look for the rate here, it's saying that it's charging me 6% interest. That is a percentage. So I know that my rate is a percentage. Okay, well, I know that I eliminated that one because it wasn't decay. And then I know that the rate is a percentage. Well, which one of these two gives me a rate as a percentage? The middle one. So that means that that's going to be the equation that I use. So I'm going to go ahead and write that down. Y equals a parentheses 1 plus r parentheses to the power of t. Okay? So again, you can't just pick any equation. You got to go through that checklist. Is it growth or decay? And then is the rate given to you as a word or percent? Once you have that, you just plug in numbers. So let's start. Let's go ahead and identify things. Remember, we have three variables here that we need to identify so we can plug in. So remember, A is your initial value. So what's the initial value here? It's going to be the 4,500. Initial means that's the number you start with. So we start off borrowing 4,500 from the bank. Okay? Then the R value is going to be your percentage, or your rate, which is going to be, in this case, 6%. But I don't want to write it as a percent, I want to write it as a decimal. Well, 6% as a decimal is 0.06, so that's the number that I want to use. Lastly, I want to identify the T. Well, the T here would be time, and what's the time? It says 5 years. Now, you don't have to worry about converting or anything like that. That's not a big deal for these types of problems. So let's go ahead and plug in what we know. So we have y equals our A value, which is going to be our initial 4,500 that we borrow. And then we have 1 plus our rate, which is going to be 0.06. You want to make sure that you write that as a decimal. And then to the power of t, which is our time, which is going to be 5 years. Now, how would you solve this? You're going to plug that into Desmos. So you can actually type in this part here. I would only type in that. I wouldn't type in the y equals. You can if you want, but it will graph it. And you don't really need a graph. We just really need an answer here. So I'm going to go ahead and write 4,500 parentheses 1 plus 0.06. Now you're like, well, why don't I just simplify the 1.06? You can. So if you wanted to, you could do 1 plus 0.06, which is 1.06 to the power of 5. So you can simplify if you want to. Again, you don't have to. Okay, and this is going to be to the power of, now I'm spamming the power button right here, it's a to the power of b, and it'll be to the power of 5. And I get 6,022. So this is a money problem, so I'm going to go ahead and round to the 0.02 for this one for 2 cents. So I get y equals 6022.02. So what does that mean exactly? Well, that means that after 5 years, you're going to owe the bank $6,022.02 approximately, because again, we did round. Okay, so again, we borrow $4,500 initially, but with the 6% interest for 5 years, we end up actually owing $6,022. So that's how you would do these types of problems. I'm going to go ahead and move to number 3, which is another exponential problem with growth and decay. So bacteria doubles every hour. If we start with 3 bacteria, how much will there be after a day? Okay, so again, remember I said that you always check to see, hey, is this a growth or decay? That's the first question you should always ask yourself. So is it growth or decay? Okay, well, it's saying the bacteria is doubling every hour. So obviously to me, that tells me it's growing, right? It's growing at a rate of twice the amount every hour. The second question you always ask yourself is the rate given to me as a word or percent? Okay, well, I don't see a percentage in here, but I do see a very important keyword, which is doubles. It's telling me that it's doubling, which is giving me a rate, which means that it's giving to me as a word. Okay, so let's go up to here and figure out which ones can we eliminate. We said it was a growth problem, so I would eliminate decay. There's no way it's going to be decay because, again, it's growing. The second part I had to ask myself is, was the rate given to me as a word or percent? And I just said that it was given to me as a word, which means it's going to be this equation that I'm going to use. I would not use this one because it did not give me a percentage as a rate. So that means that I'm going to be using y equals a times b to the power of x. All right, so remember, this is the same thing as y equals a b to the power of x with parentheses. I'm actually going to use the parentheses one just because Desmos prefers parentheses, I think. It's just easier for me to find the parentheses, so I like to use that. So let's go ahead and identify what we know. So the a value here is our initial value. So initial value is what we start with. Well, it says that we start with 3 bacteria. So a is going to be 3 in this case. All right. The b value is going to be your rate. Remember, it's your growth factor. And this is a growth for sure because it's doubling. Now, doubling is going to be our rate here. Well, what would doubling mean? It means it's a rate of 2, right? Doubles. If it's triples, it's a rate of 3. So our b here is going to be 2. That's our rate. So just like, so if it was a half, then you would put 1/2. If it's being quadrupled, then your rate would be 4, and that would be your b value. With these, it will be pretty clear cut what the percentage will be, but sometimes you have to think a little bit about the words. Okay. And then lastly, we have x. Well, what does x mean? Well, x is typically our time. So x is the time here. Okay, well, it says, how much will you have after 1 day, after a day? So let's think about this. It says it's doubling every hour, and it wants to know how much there will be after 1 day. Because the rate is given to us by hours, we have to think about the day being in hours. So we don't want the time to be 1, because if we put 1, it's going to calculate for 1 hour of growth. So if it's asking for after a day, that's going to be 24 hours, because it's 24 hours in 1 day. Again, why am I using hours? Because the rate is given to me in hours. So I want to make sure I make those consistent with each other. So I've identified all of the variables. Typically, y, we don't really plug anything in for y unless the problem's given to us backwards, but that's usually not the case. So I'm going to go ahead and plug in what I know. Y equals our a value, which is 3, because that's our starting, and our growth factor of 2, because it's doubling, for 24 hours. So I'm going to go ahead and plug this into Desmos. I'm going to plug in the 3, parentheses 2, parentheses, to the power of 24, because it's 24 hours in a day. So it looks like the bacteria grows to 50,331,648 bacteria. So that's a lot of bacteria that has grown in 1 day. So I'm going to go ahead and write that number down. Okay. So again, the hardest part is just knowing which equations to use. Make sure you ask yourself if it's growth or decay first, and then whether your rate is a word or percentage, and then you plug in all of the variables that you see fit. So with these two, you would find the a, the r, and the t, and then with this one, you would find the initial amount, which is a, the growth factor, which is b, and then your time, which is going to be typically x, because time is usually your x variable. So that is it for writing exponential equations.